In this video, I'll describe what the chi-square distribution is and how it's based on something called degrees of freedom. In the previous video, we looked at an example where we wanted to know whether some birth months were more common than others. We had birth month information from 200 people. Based on the null hypothesis that birthdays were distributed proportionally to the lengths of the months, we computed the expected numbers predicted by this hypothesis. And we computed a chi-square statistic of 5.41. In order to determine whether this statistic is strong evidence against the null hypothesis, we needed to compare it to a sampling distribution based on the null model. One way to create this sampling distribution is by actually constructing and sampling from a null model. First, we would set up a model with 12 outcomes, one for each month. Then would use the null model to assign the probability for each outcome. Would simulate 200 people, collecting the number of birthdays in each month. Then would enter the formula for the chi-square statistic, adding the contributions for each of the months. For this sample, the statistic is 4.3765, and different samples from the same model would give us different statistics. So we could simulate doing this many times, and then look at a distribution of the chi-square statistics. This is the sampling distribution generated from the 1,000 simulated samples. And if we did 1,000,000 samples, it would look like this. Now, it turns out that this distribution would have looked different if there were a different number of months in our year. So, our year had 12 months. But if our year had only 6 months, the sampling distribution would have looked like this. And if there were just 3 months, it would have looked like this. Or for 4 months, or for 16 months, or for 20 months. And one thing we can see is that, for example, when there are just 3 months in the year, the values of the statistic tend to be small. But when there are 20 months, the values tend to be larger. And this makes sense because with 3 months, the statistic involves adding 3 components, while with 20 months, it involves adding 20 components. Now, it turns out that if the data meet particular conditions, there is a faster way to generate these sampling distributions. In our original data, there were a total of 200 birthdays. So in each sample we took from the null model, from the first 11 months, we can select varying numbers, but once those have been selected, the number of birthdays in December is fixed because it has to make 200 birthdays in total. The formal way to describe this is that there are 11 degrees of freedom. 11 of the values can freely vary, but the rest are fixed by the need to add to 200. And it turns out that a chi-square distribution with 11 degrees of freedom can be modeled as the sum of 11 squared normal distributions. Sometimes a normal distribution is called a bell curve, so you'd take 11 of those, square their values, and add them together. Now, this chi-square distribution can be described by a formula, although it's a little complicated. And it turns out in order to use this distribution, all of the expected counts need to be at least 5. Now, most statistical software will be able to generate these distributions for you. All you need to do is specify the degrees of freedom. And once you have done this, then you would compare your observed chi-square statistic to whichever distribution you're using to compute your p-value. So in this video, we looked at the chi-square distribution, which is a sampling distribution that would be generated from a null model using a chi-square statistic. When there are k freely varying quantities in this scenario, we say that there are k degrees of freedom, and the resulting chi-square distribution is the sum of k-squared normal distributions. We use these distributions to compute p-values in scenarios where we are working with multiple categorical variables, or categorical variables with more than 2 possible values. And to do this, you need each of the expected counts to be at least 5.